Hi, welcome back. Just going to run through a couple of the questions that we did last day, sort of day 2 of section 2.5, where we were finding maximum minimum values on an interval. I had a student ask for a video just to sort of clarify a couple of concepts. So we're going to start by just kind of reminding ourselves what we're finding when we do derivatives. This all started with us trying to find a tangent, or sorry, the slope of a tangent to a curve at a given point. And so you can sort of see right here, the tangent that would clip this parabola at the minimum point is a flat line. Of course, if we sort of looked at the next example, same sort of thing would occur. Take that same tangent at this point right here, where there's clearly a maximum from the graph, we can see that we're just kind of clipping it with that same horizontal line. Continuing on down, same sort of thing here. There's a minimum value clearly at that point, and the horizontal line clips it. The slope of any horizontal line, you probably remember, is 0 because we're not rising at all. So if we think about rise over run, there's no rise, which is a 0 rise over the run. And so it kind of, hopefully it makes sense that the idea of derivative being equal to 0 helps us find our maximums and minimums. So as far as actually solving this question, the interval given to us is 0 less than or equal to x less than or equal to 3. The derivative of f at x is going to be 2x minus 4. I don't think there's too much trouble there anymore. And so if we determine that the possible maximum min values are the zeros, because of course, or the zero slopes, because of course that's where we get our maximum minimums on the entire curve. And then theoretically, we could also have a maximum and minimum, or maximum or minimum at the end points. Because as we sort of see on this example, if the graph is cut off right here, then this will be a maximum value, regardless of the fact that the original curve would have kept going. In the sort of the section we're talking about, which is here to here, the highest value is obviously this one on the endpoint. And so all we have to do, if we didn't have the graph, is check the two endpoints, and any values that we find have a slope of 0. And so 0, 2, and 3 are the values. Sorry, here. So when we make the derivative equal to 0, we find that that occurs when x is 2. And so we're essentially finding the y values for 0, 2, and 3. They are 3, -1, and 0. And so those are the only possible maximum minimum values in the interval given to us. So clearly that's my maximum, that's my minimum. And so just stated, the max is the value of 3. It occurs at x equals 0. The minimum is a value of -1. It occurs when x is equal to 2. And again, won't go through this too detailed. Same sort of thing here. The interval for this question is -1 through to +3. And so we're not interested in what goes on outside of that range. Sorry, outside of that domain, I should probably say. And so f prime is 3x squared minus 6x, make it equal to 0. Factor to solve. 0 and 2 are both possible values there. And so -1 being one of the endpoints of my interval, and 3 being one of the endpoints of my interval, are other possible maximum and minimum values. So we test all 4 of them. We need to determine, in order to determine whether something's a maximum or minimum, we have to determine what the y value is. And so we'll solve for each of those y values. And we can see that from the diagram, as well as from the points here, that we have zeros as our maximums, -4s as our minimums, and we can just sort of state that outright. Now just sort of a note, I did draw the graph after the fact. I found those 4 points, I plotted those 4 points, and then just from what we've done in functions, or what we did in functions, recognize that a cubic function has this basic shape, or of course this basic shape, depending on whether it's a positive or a negative graph. And then determining the endpoints allowed me to know for sure that the graph went this way. It didn't come the opposite direction. Well, I guess it couldn't come the opposite direction. Once you have the points in, I guess it's obvious what's happening anyways. And then just the last one here. I just wanted to include this last one because I clearly made a little bit of a mistake, and it's just sort of what you're expected to be watching for. My function is x plus 4 times x to the negative 1, or 4 over x. Take the derivative. That should be okay again. And then when we solve it, we find that x is plus or minus 2. And so kind of just hurrying through, I started by setting up the negative 2, the 1 for the endpoint, the 2 and the 10. But of course, what you recognize is that if 1 and 10 are our endpoints, then negative 2 cannot be part of our solution. And so of the values that we wanted to consider, the 1, the 10, and any x's or any zero slopes in between, 4 is my minimum, 10.4 is my maximum. And so there's the solution. And again, see here, we didn't draw the graph because of course we don't have to. The idea is the rules are the endpoints can be maximum and minimums. The zero slopes can be the maximums and minimums, and there are no other possibilities. So when I look at the values, 4 is clearly the smallest, 10.4 is clearly the biggest, and I'm done.